A volcanic eruption appeared imminent in Portugal. Thousands of earthquakes were rapidly occurring one after the other, the ground had notably rose, and fresh magma was detected at very shallow depths. And yet, right when almost every scientist monitoring the situation, myself included, expected a volcanic eruption to soon begin on the Azores island of Sao Jorge, one never came. Instead, the worrisome episode of volcanic unrest in 2022 seemingly stepped back from the brink of disaster as 79 million cubic meters of magma solidified, reaching within 1 mile or 1.6 kilometers of the surface. It is now 4 years later, and a new scientific paper helps to explain why an eruption did not occur on Sao Jorge during March 2022. I used mathematics to determine how close the island of Sao Jorge got to producing an on-land eruption in 2022 and where it might have occurred using a starting point of data contained in this linked scientific paper. The answer? Sao Jorge was somewhere between 65 and 90 minutes from producing a volcanic eruption at 11:40 p.m. local time on March 19, 2022. Such an eruption, if it were to have happened, would have had some degree of explosiveness to it in my opinion, and that eruption would have been most likely to occur on all or parts of this modeled 4,000 meter long fissure that would have formed. However, I do want everyone to take that modeling of mine with a grain of salt, because not only did the aforementioned scientific paper note that the exact tilt of the magma dike intrusion had multiple potential interpretations which worked, but also because the conditions never truly were sufficient for an eruption to happen. Per a direct quote from that scientific paper, a primary explanation for stalling at this shallow depth is that the volume of magma, and hence the resulting overpressure, may have been insufficient to overcome the lithostatic and edifice-related stresses at shallow depths. In my interpretation, this is probably due to not enough volatiles being present in the rising magma body. Typically, as magma intrusions rise to shallow depths in the crust, gas comes out of solution and expands, and this expansion propels the magma upwards. If not enough gas exists, then an intrusion will fail to reach the surface and produce an eruption. This is why most magmatic intrusions around the planet fail, as their magma stalls in the crust and solidifies. In the case of Sao Jorge in 2022, the magma intrusion stalled at essentially the base of the island's edifice underground, and magma was unable to overcome the strength of the rock and thus break through it at this boundary. What made the magma intrusion quite interesting was the absurdly fast rate that it rose at, jumping from 26 kilometers below sea level to 1 kilometer below sea level in a time span of only 22 hours. That's unusually fast for a magma intrusion, but similar instances have been noted before at other world volcanoes, so it's not unheard of, just rare. What was worrying is that the intrusion was almost completely aseismic, that is, without earthquakes, until the intrusion reached a depth of 9 kilometers. By the time the first detection of earthquakes was made, it would have only been 330 minutes before an eruption commenced if the correct conditions had hypothetically existed for the magma dike to break through overlying rock all the way to the surface. The seismicity which did occur was only detected when the magma intrusion was on a section and not full extent of the dike, specifically only between 5 and 9 kilometers depth. For much of the first day, magma was either at deeper or shallower depths than this range, not producing any earthquakes. This occurred because the magma intrusion used a pre-existing path of least resistance to intrude upwards, specifically the Pico do Cavaro fault zone. That fault gave the rising magma a rapid pre-existing pathway to travel through without generating any earthquakes or ground deformation until somewhat shallow depths were reached. In fact, the vast majority of earthquakes and the highest rates of seismicity only occurred after the magma intrusion had already stalled and had started to solidify. Most of these quakes occurred at 9.5 to 13 kilometers depth, specifically being triggered by lateral releases of small volumes of magma and magmatic fluids to the west, going into the Pico de Cavaro fault zone to end up triggering months of elevated seismic activity. The magma involved in the 2022 intrusion is still solidifying and in my opinion will not ever resume its upward motion at any point in the future, being destined to eventually solidify as mafic igneous intrusive rock. Tune in tomorrow to learn why the nature of this intrusion in 2022 has implications in terms of world volcanology, in my opinion has the potential to somewhat change the way we currently monitor volcanoes worldwide, and may even explain why at least one recent deadly volcanic eruption on a completely different continent happened. As a final note, I would like to thank my new patron D_AVK for supporting my work via this channel's Patreon page.